Hi there, welcome back. In this session, we are going to talk about the ReRanker. What is ReRanker, how it works, and then we are going to implement a ReRanker, and then we are going to see a ReRanker before and without ReRanker and with ReRanker. So in the last session, we have built a basic RAG application. In this session, we are going to enhance that RAG application with a ReRanker. And then we are going to run the same question without ReRanker and with ReRanker. And we are going to compare the results, like which is a better answer you are getting. How we are going to do? We are going to build LLM as a judge type of a method where we take the both with ReRanker and without ReRanker and pass both of them to an LLM as judge functionality to evaluate which is a better answer. With that, let's get started. Now let's look into the ReRanking part. Right, so what is ReRanking? First, let me show you a simple infographic to show you like at very high level what is ReRanking. ReRanking nothing but say you have a query, you retrieved 3 chunks, okay, or maybe 4 chunks. Maybe chunk 1 is not shown in this diagram on the left hand side but shown on the right hand side. That's okay. Say you have a query, you retrieved say 4 chunks. What the ReRanker model does is it will rank the chunks based on which are more relevant chunks for this query being asked. It just not semantically closer to the query, but whether they're how relevant these chunks are to the query. So that's what the ReRanking is all about. To summarize, ReRanking nothing but to reorder the chunks which are very relevant to the query and then give a relevancy score, and so that we can pick up the chunks which are very relevant to the question being asked. Right, now going back to this here, so with an example, for example, what happens is typically say you have the question like what was Tesla's strategy for cost reduction 2024. So initial vectors let me return you like chunk about some 2024 vehicle production, chunk about the factory output, some codes on Elon Musk, maybe chunk about cost reduction. So the ReRanking what it does is it will see, okay, for this question which chunk is very relevant. For example, a chunk about Elon Musk code might not be very relevant to this particular question being asked. Maybe then it gives a lower relevancy score for this chunk. That means this chunk will be in the bottom, it won't be in the top, because we pick only the top 3 or top 5 of the chunks which are very relevant. That's what the ReRanking does. So how it works? So before that, let's understand something called a cross encoder model. So what is a cross encoder? It is a type of a transformer model that will take both a query and document and process them jointly as a single input sequence. So the reason being the why it helps is when you're looking at, for example, you take this question, when was the Tesla was founded, and then there is a document which says now the input for the model will be like, for example, the CLS means a classification token, a separation token. So now you pass the when was Tesla founded as a one, this combined input is passed to the cross encoder model. So now this cross encoder model can compute a relevancy score. It knows now it can look at the question, it can look at all the chunks, and then it knows that which chunk is very closer, because there have been these ReRanker models are trained on that to identify the chunks which are very relevant to the question being asked. So how this is different from the bi-encoder model we have used, right? In case of the earlier example, when we built the basic RAG, we have taken the question, we created an embedding for that question, and then we went into the vector database and we're seeing like which embeddings are closer, right? That means here the encoding is happening independently. You are encoding the query and the doc separately. But in this case, what is happening is in cross encoder, you are encoding them jointly, because the query and the doc are put together as that is the encoding style. Now there is a trade-off. This cross encoder model or the ReRanker might give you high accuracy, but you suffer the speed and then the scalability aspect. So it comes a trade-off. That's why, because you have to first retrieve all the document chunks and then pass it on those chunks to the ReRanker. So obviously it is going to add a latency to your uh, retrieval process. So to talk in a plain English, how the re-ranker works, right? Say for example, if I take something like Cohere re-ranker, so how does it works? You pass the model, the question plus chunk together, so that model will tokenize both the query and the chunk. Now it'll think like this. It'll first understand the meaning of the question being asked. It understand what the chunk is talking about, and compare the two and look for a deep relevance. So I'm talking very plain English. I'm not talking very by-encoder architecture how it was internally. But this is, if you want to talk in very plain English, this is how it works internally. Now based on the relevancy, it is going to give you the relevancy score for each chunk. Like 0.95 is very relevant, maybe 0.2 is not relevant. So if you have 10 chunks and then you pass all the 10 chunks on the question to a re-ranker, the re-ranker will assign the relevancy score for each chunk. Now you are going to pick up the chunk with highest relevancy, or maybe top 3 relevancy or top 5 relevancy. That way the context you are passing to the LLM to summarize the answer or answer a question, the context is very relevant to the question, right? Now there are a lot of re-ranker models or cross-encoder model available in the Hugging Face or which you can use, but in this case I'm using for our example, I'm using a Cohere re-ranker. The reason being, it's kind of API based. It's kind of easier, and of course, it is a paid one. You need to go and register, but it is having a trial token. The trial token actually has very generous, token where you can get with the trial API key. You can actually almost make, I think, more than 10 or 15 API calls per minute, I guess. So it's kind of easier for if you want to test something, you want to learn something, the Cohere re-rank, and it also gives you very high quality relevance score. And then and it's very easy to use, and you can actually with very easier to use code, you can basically just have, all you need to use API key, and then you can pass all the chunks and question to that API, and then it will compute the relevancy score for you. Now let's look at the code part. So now I wrote a new method. We have new method called get rag answers Cohere re-rank. So here we are getting the Cohere API key from the environment variable which we loaded initially, and then we are going to create the Cohere client using that Cohere, because I'm importing this Cohere library. The step number 1, we retrieve the chunks. So the query is being passed to this method. So for this query, I'm going to embed this query, and then I'm going to index using our index which is there in the pinecone. I'm going to retrieve this query. Right now this will give me the list of chunks. Okay, and now what I'm doing is this is what just I'm printing some chunks, like see the metadata and everything. Next I'm going to invoke this re-rank method where I'm passing, this is my re-rank model I'm using, this is a query being used, and the documents for re-ranks. This documents for re-rank is what I have retrieved this re-rank, this chunks from the pinecone, and then I want to pick up the top 5 documents and return the documents. So now once I return this, I get the re-rank response, and then from the re-rank response I get all the chunks, I get all the metadata. So I'm printing all the what chunks I got, because I just printing here so that we get a visibility into what were the chunks before re-ranking, and when the chunks, when re-ranking happened, what chunks we are picking up. And rest everything is same. We are having the same question, we are passing the question context, and I'm asking putting some instructions, and then invoking this one and printing the response. So let's first execute this method, and then I am already written one more method called evaluate answers. So where we are passing answer 1 without re-ranking, and this is with re-ranking. So we are actually comparing which answer is a better answer. So we are forming a prompt where we are saying your expert evaluate task comparing two AI generated answers. We are putting answer 1 without re-ranking, answer 2 with re-ranking, and then we are putting evaluation criteria, and then what is it, what we should look for, the accuracy, the completeness, relevance, the clarity, specific details, and then we are asking you to tell me for each of the, what is the final verdict, for each of the chunks, answer in each of the sections, what is the final verdict, okay, what is the confidence level and who is the final winner. And then this is what we are using LLM. Instead of just we comparing blindly, we are using an LLM to compare the output of my RAG application, my RAG, the query. So let execute. Now this is where I'm having this question: summarize Amazon's R&D spending in 2024. So this is a plain RAG which I wrote in the last session. I'm going to invoke that with this session. I'm going to print the answer. Then I'm going to ask the same question with the cohere re-ranking. I'm going to print the answer in the next cell. We are going to take both the answers and then compare them. So let's execute this cell and then we'll see like how the chunks are being retrieved. Now we can see that in the first case it retrieved these chunks. You can see that sometimes it is retrieving chunks about Nvidia, Amazon, Tesla, everything. Even though if the question is on Amazon, we're still getting some chunks related to Nvidia because maybe it is looking for the R&D spending 2024. All these things it is doing this cosine similarity. It is finding all the chunks. Now it has got, these are the chunks. Next we are doing the re-ranking part. Now we can see that chunks before re-ranking and then chunks after re-ranking. So chunks before re-ranking, it is taking chunk 1, 2, 3, 4. It ranked 5 relevant chunks, and then it has, of course, it still has got some chunks related to Nvidia, Amazon, Apple, but number of chunks it is picking up is less now. It is actually looking at the executive compensation. It is looking at the business. It is looking at the business risk factors and everything looking at. Now it is giving you the results. Of course, you could see at the outside, you could compare the results. Basically, this compared to this response is giving you a little bit more focused, more specific on the numbers. But instead of but let's give this answer to the LLM and then ask it to compare. Like now we can see that this is answer without re-ranking. This is answer with re-ranking. That's what we have done here in evaluate answers. The first one, answer 1 is without re-ranking. Answer 2 is with re-ranking. So we are passing two parameters, parameter number 1 without re-ranking and with re-ranking. Now let's execute this evaluate answers. Now we are passing both the answers we got without re-ranking and with re-ranking, and then asking LLM to evaluate which is a better answer. This is very interesting. Now we need to see like what is the outcome of this particular LLM evaluation. How does it ranks this one? So it will take some time to evaluate these answers. Because now we are it is evaluating on all different parameters. We are giving evaluation criteria, what is accuracy in factual correct, which one is more content accurate information, which is completeness, which is very relevant, which is very focused, right? We are also giving a detailed analysis we want to do, like what for answer 1, what is analysis, for answer 2, what is analysis, who is a winner, answer 1 or answer 2, right? In terms of accuracy, factual completeness. Let's see now, did we get the results yeah, now we got the results. Now we can see that accuracy and factual comparison. Answer 1 contains a factual inconsistent with the mention of Cybertruck, something Tesla related, which is irrelevant to the Amazon. But answer 2 acknowledge discriminating document 3 providing both figures but nothing lack of clarity. This transparency improves the factual correctness. So in this case, the winner is answer 2 because it address inconsistencies and then irrelevant. Again, answer 2 is 1 with re-rank. Now in case of completeness, also again winner is answer 2. It provides more comprehensive view including conflicting data and additional metrics. And then relevance and focus, it maintains tight relevance, remains entirely focused on R&D spending with no irrelevant tangents. But in case of answer 1, it stays slightly with the Cybertruck reference, which is off topic. It focuses on R&D, but it just gives you something you are asking question about Amazon and it's talking about some cyber trick from Tesla. So it tells you the final verdict is answer 2, which is the confidence level is very high. The main reason is that it is giving you the key differences, more comprehensive coverage of R&D figures, and better handling of discrepancies, and like, so basically you can read this one again when you run this notebook. I'm going to show the notebook, but the point is that the re-ranking helped to improve your the relevancy of your answer. Now the question is, there are some considerations when you are using the re-ranker. It's not that you can use one is that, for example, if you have an accuracy matters more than speed. So for example, you are doing something like a medical summaries or some legal document Q&A where you want to be more accurate rather than faster. Maybe re-ranking helps because you get a more relevant answers. Sometimes if you have a retriever and you are having a lot of noisy or very similar looking chunks which are not related to the question, maybe in that case re-ranker can help. So for example, you are having the same type of 10K documents for every company like Amazon, Tesla, and you're storing everything all together. But in ask question about Amazon and you say R&D or maybe say risk, those things are there in every document. So it might pull up the documents from all of them and then gives you the chunks. So in that case, the re-ranking helps you to eliminate that noise and then be focused on the question. And then again, the challenges is that if you're looking for a very ultra low latency response, or you are actually operating at a very large scale, or maybe you already have very strong domain specific retrieval logic, you are, whether you are having very short, your corpus is not very huge amount of data, very few limited data, maybe re-ranker might be overkill. It may not be really an optimal in that case because you are going to compromise on the speed latency. So that's what we need to consider, the pros and cons, the considerations for using re-ranking. So in the next session, we are going to talk about another technique called multi-hop. With that, let me end the sessions. Thanks for watching.